As a content creator who works with 3D printers on a regular basis, I've often asked, what printers do I actually use? 4 come to mind right away. My Voron V0.1, my Bambu Labs X1 Carbon, the Voron V2.4, and my Ender 5 Plus. One of these things is not like the others. The Ender 5 Plus has a good build volume. It's been great for my social media career as I've used it to print a lot of the bigger prints that have caught a lot of popularity for me on other platforms. And after quite a bit of modification, it's one of my most reliable 3D printers. So of course, it's time to tear it completely apart and rebuild it. As I said, this is a bit of an oddball compared to the other printers I use on a regular basis because it's fairly slow in comparison. So what we're going to do is convert this to Core XY by turning it into a Mercury 1.1. Now, plenty of companies provided parts for this project, but there's only one sponsor of this video, and that's the fine folks at Brilliant.org. Do you want to learn about the engineering principles that go into the design of the mechanical systems on your 3D printer, or the computer science that drives the firmware in it? Well, Brilliant is an excellent online learning platform that can help you achieve these goals and more. Both Ruby and I have been wanting to expand our knowledge base by adding coding to our skill sets. Brilliant has approachable and entertaining ways of teaching. Whatever your skill level, they have lessons customized to help you learn and at your own pace. The entry-level computer science course that I started even gives me experience points when I get questions right. This gamification of learning helps someone like me with ADHD stay focused and engaged. Head to brilliant.org/MandicReally to get started today for free. New subscribers get a 30-day free trial, and the first 200 of my viewers who follow that link will get 20% off their premium annual subscription. Check it out at the link in the description to start your learning journey today. Brilliant.org/MandicReally. Now let's get back to this project. I don't remember when I became aware of the Zero G team and the Mercury One project, but for anybody who's not familiar, this is an open source project converting Ender 5 Pro and Ender 5 Pluses into Core XY 3D printers. I like the Ender 5 platform, but it's been in desperate need of an update for quite some time. Creality just released the Ender 5 S1, but they haven't done the same with the Plus yet. Now, my machine is by no means stock, but we're going to upgrade it beyond what Creality would ever consider doing with an S1 variant. So let's get this torn down, and then we'll talk about what parts we're going to use for this build. While we're tearing this thing down, let's talk about what I was running on it. This is the BQ-H2, the version 1 direct drive extruder assembly. I was running a 0.8mm nozzle in this the majority of the time that I ran the setup. It had a 75-30 part cooling fan to cool all that lots of plastic, the part cooling fan duct, the mounting for this extruder, the 40mm fan adapter, and the linear rail conversion on the x-axis were my own designs. Digging into the electronics box, you'll find I was running a BigTreeTech SKR 1.4 turbo board with TMC 2209 stepper drivers and my own custom compile of Marlin on it. With the electronics box out of the way, you can see there's not a whole heck of a lot that's going to be left of the original machine, and in my case, I'm also replacing the bed, so really not much. Before we start discussing my own custom challenges with this project and the way that I'm approaching it, let's discuss the parts I'm going to be using in this build. Let's start off with the hot glue gun end of things. The Mercury 1.1 uses the Ava tool carriage system, so you have a lot of options when it comes to what hot end and extruder assembly you're using. I'm going with a Revo 6. There are 3 reasons for this choice. 1, I already had the hot end. 2, E3D sent over the new High Flow version of the Revo ecosystem, and I need a platform to test it on. My Ender 5 Plus version of a Mercury 1.1 should not only be capable of speed, but also big prints, so it seems like a great place to test it. And 3, I just genuinely like Revo. I love being able to quickly swap between nozzle sizes. To try and keep up with those high flow filament demands, we're going to use the LDO Orbiter V2 extruder. This design has been shown to keep up with high flow hot ends, and I'm interested to see if the planetary drive system gives me good consistent extrusion. Thank you to LDO for supplying this for the build. That extruder gives us a segue to the electronics, because I'm going to be running a CAN toolboard on that extruder assembly, namely the BigTreeTech EBB36. I'm looking forward to running this because it's going to allow me to compartmentalize the build, having a toolhead that's really contained to itself and with a single cable running back to the electronics box to control everything. Inside of that electronics enclosure, BigTreeTech provided an SKR3EZ. This is going to allow me to have independent control of the two Z-axis motors to really level out the bed nicely and run those TMC 2209 EZ stepper drivers that stand up vertically for good cooling. I run one of these currently in Project Reanimator, and I've been really happy with it in that build. I can also interface the CAN toolhead with that board, so I won't need an additional U2C module. And the bulk of the parts are coming from the Mad Honey Badger Fabrico. When I first started considering building the Mercury One, I thought about going the route I did with my Voron, self-sourcing. The bill of materials is available, so I could order the individual parts and put a kit together for myself. But something I learned when building those machines was that on paper the prices might be cheaper, but then you have to consider tax and shipping on those individual transactions. Then you find a kit like this from Fabrico, and the price seems pretty reasonable. Let's see what comes in the box. In the box, we'll find a full hardware kit for the build. It's going to have all the stainless steel hardware we need for assembling this thing, has our pulleys to go onto our motors, idler bearings, pins for this setup because it uses pins in the Mercury One, not bolts for our idlers, shims, heat press inserts, and roll-in nuts, all nicely organized. We also have our A and B motors. These are NEMA 17 42mm motors, 2.5 amp motors, so nice strong ones to really power this system at higher speeds, hopefully. Rounding out the rest of it, we get a 2020 extrusion that's cut to the length we need for this specific build because we need to replace the X-axis gantry on it. We get triple MGN 12 stainless steel linear rails, pre-lubricated, and they feel nice and smooth. Love to see that. And lastly, we've got a new higher wattage heater element and a thermistor to go with that for upgrading whatever hot end we might be using. I, of course, won't need those. Now, the second box is optional stuff, not stuff that comes in the Mercury One kit, but things I wanted for this build, such as we've got a new 200 watt Meanwell 24 volt power supply. I could have used the 500 watt that comes with the Ender 5 Plus, but I wanted a fanless one. Also a 5 volt power supply for the Raspberry Pi, and the Honey Badger edge to edge 1000 watt heater element for my bed. Because a big bed means big power. Any other parts we'll talk about as we get to them. Now it's time to worry about the frame we're building atop of. The Mercury 1.1 largely just builds on the top section of frame. There's not much else to it other than an electronics box at the bottom. I don't necessarily need to, but I want to reinforce my frame at least a bit before we build the Mercury 1 setup atop of it. I do need to reinforce because of this extrusion that's missing in the front of the machine. I removed that because it's difficult to see your first layer with that in place, film content, or remove smaller prints from the bed. And it really annoyed me. I have these gusset reinforcements at the bottom of the frame, but I've redesigned these and updated them for this particular build. Now, something I wasn't aware of until I started this assembly is this front corner of the frame here doesn't have anything holding it together without that extrusion piece in place. The original idler bracket and the top extrusion bar, as well as the reinforcement piece that goes to that, are all that held this corner together, so right now it's free floating. As such, I specifically designed a couple of reinforcements for this. A fish plate to go on the outside, tying the upright to the top extrusion, and an inside gusset that caps off the top of the extrusion, so you're not going to be cutting your arm when you're reaching into the machine, and to tie the top extrusion in more. I previously showed this cap piece in my Ender 5 S1 video with the Sonic pad, but I originally designed it for this machine. But before I get too deep into the brackets I'm adding onto the frame, I think it might make sense to start from the bottom up. So I'm going to flip the machine over and start building the electronics enclosure that mounts to the bottom side of the original framework. I really like the aesthetics of this design, plenty of airflow, it's got the 0G logo in the middle, and overall seems to be pretty well designed to fit this machine. With all that together and the new feet on the machine, I can actually put my new braces on the frame to start stiffening things up. These are printed in Polymaker ABS, same as all the rest of the parts. Something I dislike about the Ender 5 frames is the exposed cutoff ends of the extrusions at the front of the machine. The Mercury One belt tensioner covers this, but first I need to grab one of my favorite cutting fluids, this Rapid Tap. That'll go onto this M5 drill tap combo bit, so I can tap the end of that extrusion for some hardware. Those newly tapped threads plus a roll-in M5 nut allow me to install this, my own personally modified version of the Mercury 1.1 belt tensioner bracket. It caps off the end of that extrusion quite nicely, and I like the way it looks. To cap off the bottom end and just kind of clean up the bottom of this frame, as well as maybe provide a little more stiffness, I designed these corner brackets that just wrap around the corner and cover up the end of that extrusion too. Any more details of bracing up the frame we'll cover once we get the motion system together, which is what we're going to move on to now. I mentioned earlier that this design uses pins instead of bolts for each of the pivot points, so we need to sand down those pins. The inside diameter of our idler bearings and the outside diameter of the pins are effectively identical, and that doesn't really allow for anything but a press fit. So we need to sand down ever so slightly on these pins so they'll actually easily slide through the bearings. We want a tight fit, not a loose fit, but it does need to be able to be assembled easily. With a handful of pins prepped, I'm going to move on to assembling the motor assemblies. There's 2 printed parts, a stack of shims and idler bearings, and then the motors that make up these components. There is some instructions on the Zero-G website about the shim stack, so you get all of that right and have your dimensions where they need to be. With my motor assemblies together, they'll be ready to go onto the frame, which we'll get to in just 1 second, but I want to get to the last thing that there are really instructions for currently. That is the belt tensioner / front idler. I customize these, like I've done many of the components on this project, to match the aesthetic that I'm going for on this build with the pink and black and geometric shapes. The assembly here is pretty straightforward. Again, there is a shim and idler bearing stack with pins that press in through the top after they're sanded down to fit. I have customized these quite a bit, so I can't say if I got something a little bit off, but this kit came with brass shims that seem to be a little more precise measurement than the stainless steel shims, but I ended up using stainless steel shims here because the brass shims were a little thicker and wouldn't fit into these idlers. This may be my own fault here, I don't know. I was able to get these assembled with the slightly thinner stainless shims, so I don't think it's that big of a deal. And as of today, filming this video, that is where the instructions end for this project. I'm gonna have to go off of the CAD model moving forward through this build. If you are looking to do one of these, check the Zero-G team's website. I know they are actively working on documentation to go with this, so there should be more instructions in the not too distant future, but for right now, I've kind of got to work myself off of the CAD model, which I'm pretty used to doing, so let's go forward. 2 5mm bolts mount the A and B motors to the top of the extrusions. As there's only 2 bolts mounting things, it's a little easy to get out of alignment with this, so I just had to pay close attention and I was able to get it in position. The belt tensioner idler tower has a single 5mm bolt that goes down into the top of the extrusion and a single M3 screw into a heat press insert that pulls back on it to tension the belt. The stainless rails from Fabrico came pre-lubricated. I just wiped down the excess and then I was able to install them onto the extrusions. They have an amount of preload I would call confidence inspiring. Not so loose that I'm worried that after a few prints they're going to be loose on the rails, but not so tight as to cause any major drag. I think a quick break-in and they'll be really solid. With those installed, I can move on to the X gantry. My printed mounts mount to the carriage blocks on the Y-axis rails, and then the Fabrico included extrusion that's already cut to length drops into those pretty smoothly, and that's the start of the X gantry. Assembly of the shim stacks for the idlers at each end of the gantry is somewhere I really had to pay attention to the CAD model, because these stacks are different between the smooth bearings and the toothed cog gear that goes on here. The printed parts that are used, the spacers, are different between each of them. This is something the Zero-G team is really going to have to pay attention to in the documentation to make this easier for folks to understand what they need where. Linear rail installation was straightforward. I used some blue Loctite on the screws for these so they won't come loose, and checked the CAD model for the measurements as to where the rails needed to be spaced on the extrusions. With the X gantry in place, we can move on to the toolhead. The Mercury 1.1 uses a modified version of the Ava 2.4 carriage, and I modified mine further. I can't leave anything alone, so I tweaked it to some of my own tastes. I made everything heat press inserts instead of slide-in nuts, though I think there are now available heat press insert files from the Zero-G team, and I also made some aesthetic changes we'll see later. We're not to wiring yet, but the first step of installing the toolhead is to solder a couple of wires to the X-axis limit switch, because the bracket that gets first mounted onto the carriage of the linear rail sandwiches the limit switch in between the bracket and the carriage block. The rest of the toolhead carriage goes together pretty straightforward. It fully encompasses around the extrusion for a really nice stable design that just makes sense. I'm also going to be using a clicky probe for bed leveling, and that uses this magnetic mounting setup on this air duct that I got off of the 0G Discord for this build. I of course had to pre-insert the wires to this thing, as well as glue in the magnets to the duct. Then comes everybody's favorite part of a Core XY build, belting. Wrapping your head around the path that the belt has to travel and getting it all nice and tight by hand before you start pulling it with tensioners. It's such a fun time. But seriously, it is a lot of fun just to spin and dance around the tool head once the belts are in place. The Revo 6 hotend that I'm using is a clamp mount design, so it's going to get sandwiched in between a couple of brackets on the face of the carriage by a 4020 maglev Sunon fan. I went with this size of fans because I want it to be quiet but still move a fair bit of air. And to finish that off, since I think the Ava toolhead is kind of ugly, honestly, really customizable. I get why it's popular, but I don't like the way it looks. I designed this shroud that's going to hide the fan and kind of cap off the front of the toolhead, including a pair of stealth burner style LEDs to light up the nozzle area. I really like to be able to see my nozzle to pay attention to extrusion, so I also left it wide open to get a nice view and easy Revo nozzle changes. With the motion system done and the toolhead largely assembled, it's time to get the electronics box and all the components in there so I can dive into the oh-so-fun task of wiring this whole thing up. I already made some acrylic panels for the bottom of the electronics box using the X-Tool P2 laser that I have now, and now I've got to go cut some DIN rails to mount everything to. With the rails cut to length, they're easily installed into the machine, and then I can start laying out my electronics. And this is one of the things I love about DIN rails is you're not fixed into one configuration. I can move things around, switch them up, and decide what's going to work best for me to get the cleanest and most serviceable wiring in this configuration, because there will be a clear acrylic top on this, so you will see the electronics at all times on this build. However, you might notice a conspicuous omission from this electronics box, the Raspberry Pi 4 that's going to run Clipper. This came to me via the folks at Obico, so thank you to them. And it's going to mount inside of its own custom designed housing with a BigTreeTech TFT50 touchscreen interface. The Pi 4 mounts to the backside of the screen. I have my own 40mm fan mount on this thing to keep it cool, and it all mounts into the side of this housing that mounts to the front upright on the machine. Now with that Pi and screen installed on the machine, it's time to move on to the bulk of the wiring, most of which I have to do for myself. I'm not going to film this portion of the project because trying to stay focused on this with the way my brain works is already difficult. Filming it makes it take significantly longer, and this project has already drug on for way too long. So we're going to jump to when this thing is up and running and do a final overview of the last details and what I really think of the Mercury 1.1. And I am so glad I did not film the wiring process. I filmed a few snippets in between we'll talk about in a second, but this thing is finally pushing plastic. It was an adventure to get to here. Oh, the print is done. Let's throw it back to Past Alan a few minutes ago. Past Alan here. This print may not be flying right now, but it kind of is. It's pushing a lot of plastic. That's a 1.2mm Revo High Flow nozzle, pushing a 2.1mm extrusion width out of it at a 0.96mm layer height. This print is currently pushing 34.8mm cubed per second print volumetric flow rate. Now, I started seeing some under extrusion indications around 33mm cubed per second, so I would probably go more like 30 for what I would actually want to push out of this thing. But for the very first print that I'm doing, for the very first time using the Revo High Flow nozzle, I'm already impressed and have a lot of possibilities in mind for what we're going to do with this thing when we get to more print testing. Let's talk about the troubles I had wiring this thing up. As I'm intending to put clear top panels in the electronics box, I wanted to do a really clean wiring job. So that definitely took additional time versus just running wires from point A to point B. I really wanted to try and do it as cleanly as I could, and I think I'm really happy with the way it turned out. It could have been a little better, but most of the issues are from other hiccups that rose up along the way. Such as, I know I said I was going to run the CAN wire directly to the SKR3 because there's a port on that board for it. I just couldn't get it to work worth a damn. I tried and tried. I could get the UUID, I could detect the Toolhead board, but I couldn't get Klipper to communicate with it or the MCU. It was just round and round for way too long. So I finally gave up, said I do not have time for this, and put a U2C module in here. That still took too long to get configured properly, but I did get it up and running, and now I have the SKR3 and the Toolhead board both on CAN, going through the U2C, communicating to the Raspberry Pi. I really believe that BigTreeTech has some of the best documentation on the market for their boards, at least compared to other manufacturers, but there are absolutely some holes, especially when it comes to CAN stuff. The Omron solid-state relay that sends power to the heated bed, I fried one of those in this build. Not the first time I've done that, unfortunately. I did it the exact same way the last time too. Brain farted, I hooked up the wires backwards, sending 120 volts into the 24 volt side of it, and just burned it out. Continuing with things that I screwed up, because I'm in crunch time for ERF 2023 right now, I burned up one of the Z-axis motors on this by sending 1.5 amps to it instead of 0.5 amps. So I put a pair of LDO motors in place of the Creality motors on the Z-axis, which should just be better all around, but I'm going to have to replace those in a 2.4 kit I have now. Unfortunately, that's not the only motor failure I seem to have had here. The extruder motor on the Orbiter V2 out of the box seems to have been bad. I can't say if there wasn't a configuration issue here, but I am running the exact same configuration as when I had that motor on here, and I'm running another LDO 36mm NEMA 14, exactly the same motor that is now extruding just fine. So I don't know what the heck happened, but we're back up and running with a new motor there. I spent entirely too long trying to rotate the GUI on Klipper screen with this whole portrait orientation I have mounted here. I just cannot get it to work. I can get the pictures to rotate just fine, but the touchscreen buttons, they don't go with it. So the orientation of them stays in landscape, so I can't really tell where to push any of the buttons that are on the screen at any given time. If anybody has any idea of how to make this happen, portrait orientation with Klipper screen on a Pi 4 with a BigTreeTech TFT50, please let me know. I like this setup. I'd like to leave it here, but at the moment, I have to turn my head just to see it. I've got a few configuration issues that I've got to work my way through here, but there is one more thing that I kind of would like input on from you folks about this machine. This is the least responsive Klipper instance I have ever run on anything, and I've installed Klipper on a netbook in the past. It's running a Pi 4B with 1GB of RAM. It's not limited in processing power, but commands are the slowest reacting on this machine of any Klipper instance that I have personally run. Such as if I pull filament out of the filament runout sensor, it will not respond for upwards of like a minute before it'll say, oh, we got to park, you ran out of filament. Or if I send a command to cancel the print, it's going to be a while before it actually stops and cancels the print. It's simply been a little strange. I have less powerful setups running Klipper without the response issues that I'm having here. Oh, and before we get to the final details that I put on this machine and stuff that I'm really liking here, there's one more thing. It's not really a wiring issue, but there is something I think should be addressed. The Zero G team, they have the electronics enclosure, which is really well ventilated, but it doesn't have any fan mount provisions at all. I could just VHB tape a fan to the acrylic on the underside of the electronics box, but that's not nearly an elegant solution for what I'm trying to put together here. I'm going to design up my own fan mounts, but I really think they should at least include a 40mm fan mount for the DIN rail or something, because currently I'm running TMC 5160 RGB, the new stepper drivers from BigTreeTech. Side note, they're not actually RGB, it's really a misnomer. They're more like R, B, and P, red, blue, purple, and that's pretty much all they are. It just indicates the temperature of the driver. Blue is fairly cool, red is hot, purple in between. Mine are running red because I don't have any cooling on them. They're completely passively cooled, currently running at like 1.51 amps I think I got these set to at the moment, which I'm not even pushing this thing that hard or long prints yet. I've got to get cooling for the electronics box in here. All the problems that would have made me go bald prematurely if I didn't already out of the way, let's talk about the stuff that I did to button this up that I'm really happy with. starting with putting a Z limit switch on here. Now I'm running clicky probe, and I could use that for Z-axis homing, but I didn't really want to do that for a reason we'll talk about in a second. I wanted to have a physical Z limit switch on this project. So what I did is I drilled the 2 half extrusions underneath the bed of the Ender 5 Plus so that I could put a regular 2020 extrusion underneath of there. That provides a solid mounting point for the Uwu Sexbolt Z end stop that I mounted on here. Yes, that's a real thing. It's a mod for a Voron. It's the Z end stop switch I run on my 2.4 and now on this Mercury 1.1. This setup takes the hot end nozzle and probes it off of that end stop switch to home the Z axis. The reason I wanted this is Z auto calibration, a plugin for Clipper that allows probing off of the nozzle tip as well as the probe, in this case clicky probe's body, to decide the difference in height between the two of them. So I don't have to set Z offset on this machine. After I dial in the initial calibration of it, I can swap out Revo nozzles all day long, and before every print it will check the Z offset for itself, and I don't have to do anything else. I've been running this on my Voron 2.4 for a while and I love it, so I had to have it on this machine too, especially with the Revo hot end where I will be changing nozzles constantly. It just makes sense. Speaking of those, I designed this 8-place Revo nozzle holder that I installed on the upright extrusion in the front of the machine, so I can easily store those when I don't have them on the hot end. I actually designed this sometime last year when I intended to start this project, so it only has 8 positions. Now we have a wider array of Revo nozzles available. I probably should remix this to even bigger. In pursuit of keeping the wiring clean, I designed a custom Z-chain mount for this thing at the back left corner of the bed, just so I keep it nice and organized and out of the way and match the aesthetic of the rest of the wiring on this build. I also designed a Wago mount and strain relief for the bed wiring at the back side of the bed so that everything can be organized and I can replace components as I need to. If something burns out or I need to remove the bed for servicing, I can do that here. Speaking of that bed, I'm running a Precise Printer Parts MIC6 bed on here that has a groove in the top of it for a thermistor. That's the one that I use to set my bed temperature off of. So I'm not reading the temperature at the bottom side of the bed, but the actual print surface, or closer to it anyway. I run beds from this company on my Voron 2.4, 0.1, and one of my Ender 3s, and I'm really happy with them, though it's really interesting to see the stark temperature difference between the top of the bed and the bottom of the bed. Let me know if you'd like to see more about that. For my CAN cable going from the U2C to the toolboard, I crimped up my own using constant flex cable that I got from McMaster-Carr. This is specifically intended for robotics and machinery applications that are going to be continually moving. So the sheathing, the wires inside are all really reinforced for this purpose. It's also double shielded, so signaling like what we're doing here will be really well transmitted and not interfered with by other things like the motors or the power supply. As far as my tool head and the shroud that I designed for the fan and to complete the look of it, I really like the way it looks. The overall tool head is big. From front to back, it's pretty large, but I still think it looks good. I really like those Stealth Burner-esque LEDs that I added in here. They light up the nozzle really nicely and really put it on show. Though I do think I'm probably going to want additional LEDs on this machine once it's on the shelf where it's actually going to live. I'll decide that later. And on those positive notes, I think that's where we're going to leave off with the build of my Mercury 1.1. I originally intended to do prints and a whole shoot and match when it comes to this video, but honestly, it's already longer than I wanted a video to be, and I've got to get ready for ERF. I'm leaving for it in like way too soon, and I'm going to be building a full Voron Trident live at ERF, so I'm already burned out from building this machine and everything that went wrong here. Hopefully I used up all my bad luck on this build and not that Trident. So look out for a video real soon where I will put this thing through its paces and test it to the limits. I'm going to be printing big things with it. I'm going to be printing fast, and we're going to play around with that Revo High Flow setup on here and see what we can get out of this machine, as well as, of course, button up the last few things that are off about it and hopefully fix a few of the little minor issues I've had with it. So if you're interested in that, get subscribed, And let me know in the comments, what would you like to see out of this build? What more would you like to know about this Mercury 1.1? I am really excited. Seriously, I'm really happy with what I have here. I'm exhausted at this moment, so it's hard for me to translate that right now, but I think this thing has a lot of potential. All right, folks, that's gonna wrap it up for this one. I hope you found it interesting. If you did, maybe you'll find one of these videos interesting too. I don't even know what ones I've put up here at this point. I am too tired. I've gotta go to bed so I can get ready for Earth tomorrow, and it's just, there's so much on my plate yet. Anyway, see you folks. Thanks for coming around.